In this video, we're going to start section 2.3, which is going to start looking at polynomials in general. We had already talked about quadratics, which are certainly a form of polynomial. But now we're sort of going to, look at all of them. All right, so to start, we're going to just practice some good old-fashioned long division. No calculator, please. Go ahead and remind yourself how to do that. Hit pause and do some division. All right, so 76 divided by 12. 576 is known as the dividend. Easy to remember that because it's inside the division symbol. So 576 divided by 12. 12 is the divisor. And so we look to see how many times 12 goes into 5, and it doesn't. So we go 12 into 57. And let's see, that looks like 4. 4 times 12 is 48. So then I multiply by that, and now I find out how far off from 57 I was, so I subtract. I got a carry here, borrow from the 4. 17 minus 8 is 9. Gives me 96. 12 goes into 96. I'm going to say probably 8 times. Let's find out. 8 times 2 is 16. 8 plus 1 is 9. 96, remainder of 0. All right, so what have we learned here? Well, number one, we've remembered how to do long division. And then we've also found some things. I found that 576 divided by 12 had a remainder of 0, which tells me what? 12 is a factor of 576. That's one thing we know. I guess I also learned that 48 is a factor of 576. And I learned that because of those two things, we know that 12 times 48 equals 576. All right, but mostly what we did is we remembered how to do long division. And that's important because we are going to do long division with polynomials today. This is important because it's going to lead us to some theorems that are going to help us get a lot of work done, and they involve division. First up, we're going to do some long division here. And so I'm going to set this up. I'm going to divide 6x cubed minus 19x squared, 16x minus 4. And I'm going to divide that by x minus 2. So I'm setting this up exactly like I would have with the numbers. And now I'm going to do a variation of what I just did. Now, instead of asking myself how close we can get to, the number like we did before, what I'm going to really do is ask myself, what do I need to multiply? We're just going to focus on the x. What do I need to multiply the x by to get exactly 6x cubed? And the answer to that question would be a 6 and an x squared. Said another way, if I divide x into 6x cubed, I get 6x squared. But I kind of like to think of it as what do I need to multiply by? Seems to serve me pretty well. Now, just like I did with long division with numbers, I'm going to take the 6x squared, but I'm going to multiply it by all of this. So 6x squared times x is 6x cubed. And if you don't get exactly that number or that term, then you picked the wrong thing. We need it to be exactly that term. And then I'm distributing it and doing here, so I get negative 12x squared. It's important that we pay attention to our units and make sure we're lined up. Variables, not units. And so we got to just make sure that everything's lined up. And now I need to subtract. So I'm subtracting, but I'm subtracting the whole term, right? So one way I could do it is I could say subtract all of this. But for me, I find it easier just to do a little, sign change. So I'm just going to change this to a negative and come over here and change that to a positive. And now I'm going to add those together because I already took care of the subtraction part. So that gives me what? Negative 7x squared. And then I'm just going to bring down everything else. And now we go again. I need to multiply x to get negative 7x squared. So I'm going to multiply by a negative 7x. Once again, I'll distribute that times the x minus 2, giving me negative 7x squared plus 14x. Once again, I'm going to subtract, and so I'm going to change the signs. So this becomes a plus, and this becomes a minus. And now I add them together. That cancels, and if it doesn't, you did it wrong. So go back and find a better number. This gives me 2x minus 4. And one more time, plus 2. If I multiply by 2, I get 2x minus 4. And now when I subtract this one last time, I get 0. So that tells me that x minus 2 went into this evenly because I had a remainder of 0. All right, let's follow the rest of the instructions here. Divide using long division, and then use the result to factor the polynomial completely. All right, so not only did it have a remainder of 0, but that's important because if you divide something and there's no remainder, we know it's a factor. So what do I know right now? I know that 6x cubed minus 19x squared plus 16x minus 4 can factor into x minus 2 times, right, x minus 2 times what I got here, 6x squared minus 7x plus 2. So now I'm going to, because now this is a quadratic and I know how to factor quadratics, so I'm going to take a look and see if I can factor this, and it may not factor. Let's find out. I always assume that it does. 1 times 6 and 2 times 3, 1 times 2. I'm looking to add to get a 7. 6 and 2 don't work. 12 and 1 doesn't work, so that didn't work with any of them. 2 times 1 is 2, 3 times 2 is 6, 6 plus 2 is 8, that didn't work. 2 times 2 is 4, 3 times 1 is 3, there's my 7. All right, so I use my 2x and my 3x to get 6x squared, and then what did I do? 2 times 2 to get the 4, so 2 goes here, 1 goes here, and finally, because this is a plus, we know the signs are the same, and we know they're both going to be negative. Bring down the x minus 2 from before, and now I know that this factors all the way to this. All right, let's go ahead and try part B. You'll notice in part B that there is a missing term or two. I don't have an x squared or an x. It's going to be very important, more so in the dividend, what we're dividing into, than the divisor, that we account for any missing terms. So when I write this down, I'm going to write x cubed plus 0x squared plus 0x and minus 1. And what that's going to do is it's going to help things line up correctly when I do my dividing. So I hope it's obvious that this is going to be x squared as my first number, first term. X squared times x is x cubed. X squared times negative 1 is negative x squared. Notice that's why we put it in the placeholder. So now my squareds are lined up. Had I not done that, then I would have been trying to do a negative 1 minus x squared, and that would have been problematic. So now I'm going to subtract by changing the signs and adding. And so I get positive x squared. I'm going to bring down the rest of this and keep going. So I'm going to put a plus x here, because multiplying by a positive x gives me x squared, and minus x. Remember to change your signs when you subtract. And I get x minus 1. And obviously when I do this one, I get plus 1. That gives me x minus 1. Changes signs. And I get a remainder of 0. So what does that mean to be a remainder of 0? That means when I divided x minus 1, it went in perfectly, making it a factor. So I know that x cubed minus 1, if I want to factor that, it factors into x minus 1 and whatever I got for an answer, which is x squared plus x plus 1. They asked me to factor completely, so I'm going to take a look at this and I'm going to try it, but quickly I'm going to notice looking for numbers that multiply to be 1 and add to be 1. That's not possible. So it will not factor further. And so I would say that x cubed minus 1 factors into this. All right, let's try one more. Again, I strongly encourage you to pause the video and do this on your own. Look for missing terms if there are any. We got to count for every degree. In this one, I see I go from 4 to 3 to 2 to 1 to 0. So I am good. No missing terms. All right. No missing terms in the divisor either. Okay. So I need to multiply by a 2 to get a 2 and an x squared, giving me 2x to the 4th plus 4x cubed minus 6x squared. I'm going to subtract, so I'm going to change my signs. Giving me canceled out, another canceled out, a positive x squared. I'm going to bring down the rest of it. And x squared goes into x squared 1 times, so we got a plus 1 x squared plus 2x minus 3. And now I'm going to subtract, change the sign, change the sign, change the sign. And I get x plus 1. All right, once you reach a place where the degree here is smaller than the degree that you're dividing by, then we're pretty much done. And so what have I learned here? I have learned that x squared plus 2x minus 3 is not a factor. So what does that tell me? Well, this may factor, but without a hint on how to get started, because they said, hey, try this, and that didn't work. So I'm kind of dead in the water. So the best I can do is I can answer the question about what I got when I divide, but I cannot really continue to factor this. So the question then is, how do I respond? How do I answer this question? Okay. So this divided by this is equal to, in fact, I'll just write it all out to be formal, 2x to the 4th plus 4x cubed minus 5x squared, 3x minus 2, divided by x squared plus 2x minus 3 equals, and I'm going to go over here, 2x squared plus 1 plus our remainder, x plus 1, over what we are dividing by, x squared plus 2x minus 3. And I hope that makes sense, because if I asked you to do, let's say, let's go 30 divided by 4. 4 goes into 30 7 times. 7 times 4 is 28. I get 2, right? So old school would have said 7 remainder 2, but then we grew up a little bit, and what did we do? We called it 7 and 2 fourths, or 7 and a half. Well, how do you get 7 and 2/4? Well, you did the answer of 7 plus the remainder of 2 over 4. Right? So you got your answer, and then you added your remainder as a fraction. And that's exactly what we did here. Here's our answer, and then we added our remainder divided by the rest of it. Okay, hope that makes sense. Let's keep going. Let's talk about a little thing called synthetic division. You've obviously done this before, so let's review this. When we are doing division with polynomials, if our polynomial that we're dividing by, if our divisor is of the right form, then we can use something called synthetic division. And the form is we have to be dividing by something that's of the form of x plus k. Okay, and actually, usually I think they refer to it as x minus k, but that doesn't really matter right now. So, in other words, our coefficient has to be a 1. It has to be x to the first power, and there has to be then a constant. So we're just talking about x plus 2, x minus 7, x minus 3. All of those things work. Okay? So if you recall, the way we did this is we took and we grabbed the x plus 3, but we took the opposite of the plus 3. So I'm going to use a negative 3, and I'm going to set up my box, and then I'm going to grab the coefficients, making sure to pay attention to anything that's missing. So you'll notice on this one, we don't have a cubic term, and that's going to be your biggest mistake. So x to the fourth is going to be a 1, a 0, negative 10, negative 2, and our constant. So 4, 3, 2, 1, no x's. All right, we got them all. Okay, so how does this work? If you remember, we start by just bringing the 1 all the way down, and we get 1. Then we just get into a pattern where we multiply and add. So I'm going to now multiply the negative 3 times 1, and I get negative 3, and that goes right here. Then I add 0 and negative 3 makes negative 3. I multiply, I get positive 9. I get negative 1. I multiply again, and I get 3. I get 1. I get negative 3, and I get 1. All right, so let's interpret what we found here. So we did long division using synthetic division, and we divided by x plus 3. And we've got these numbers at the bottom. And so if you remember from last year, this is our remainder. This is our constant term. This is our x term. This is our x squared term. And this is our x cubed term. The way I usually do it is I don't usually work backwards that way. I mean, I'm very aware that this is my remainder. But what I usually do is instead of working backwards to kind of figure out where I land, I start at x to the fourth. And if I'm dividing by an x to the first and it goes in, then I know my answer is going to be something 1 degree less, right? Because this x would cancel out one of those x's. And so I'd be down to x to the third. So I just remember it that way. So I start here and I say, okay, this 1 is the coefficient on x cubed. So I have x cubed, and I just work my way down. Minus 3x squared minus x plus 1, and then plus 1 over x plus 3. So this would be the result of what I would get if I divided this by this. And there's one way you could easily check to make sure this all works out, everything makes sense, is that again, once you divide, right, then dividing by this, resulting in this, means if I multiply these two things together, I should end up back where I started. So if I did take and multiply all of this by x plus 3, and I distribute it, I'll probably just distribute it as a chunk. So I have x plus 3 times x cubed, x plus 3 times this, x plus 3 times this, and then finally notice what happens. When I multiply x plus 3 times this, the x plus 3's cancel out. And so I won't get a weird fraction, right? Because they're all going to cancel out. And when I add all that up, it will equal x to the fourth minus 10x squared minus 2x plus 4. I think this video is getting a little long, so I don't think I'm going to do that. But just know that, basically what I'm talking about is if I do 6 divided by 3 and I get 2, then that tells me that 2 times 3 equals 6. So this is like my 3 and this is like my 2. So when I multiply, my 3 times 2 together, I better get back to what I started with. All right, at this point, I'm probably just rambling, hoping you're understanding, and you probably are. So let's move on and try another one. All right, so that where you're going to make mistakes, first of all, you got to remember to take the opposite. So we don't want x plus 2, we want minus 2. And then we got to double check. We've got cubed, squared, x, so there's no missing terms this time. So 3, 8, 5, negative 7. Make sure you write it down right. That's usually my biggest error. And bring the 3 down to start. And we multiply. Negative 6 and add. Negative 4 and add. Negative 2 and add. So once again, we have one that isn't a factor. So x plus 2, not a factor. What did I get once I divided? Because again, it's asking, what do you get when you divide these? This was a cubed, so now this is going to be a squared. So the answer is 3x squared plus 2x plus 1 minus 9 over x plus 2. This is the answer. That's the quotient. All right, I'm going to stop the video here. I'm assuming that we are doing okay with synthetic division and long division. And if not, we can talk about it in class.